Okay, here we go. Apply the power rule. It's time to step on up. Constants. If f of x is equal to c, c is a constant, what's the slope of a constant? 0. So what's the derivative? 0. For example, if you had f of x is equal to 9, then the derivative would be 0. F of x equals x. What's the slope of x? 1. So the derivative is 1. Suppose you had f of x is equal to 4x. What's the slope of 4x? 4. So it would be c. Very good. And we learned yesterday by our proof that the derivative of x to the nth was... Nope. That's all we have to do. That's the derivative. And if you want to take derivatives of two functions added together, simply take the derivative of each one and then find their sum. So the product and quotient rules are different. We go over those tomorrow. So Tuesday. Yes, we have a math test on Tuesday. We have a math test on Tuesday. Study guide tomorrow. What's that? Well, stop by 7th hour or something. I'll give it to you. I'll print them off. Monday and Tuesday. Okay. All right. Let us find the derivatives. The derivative of 5 is 0. The derivative of -8. 0. The derivative of 4x. The derivative of -3x plus 5. I first take the derivative of -3x, which is -3. Then I take the derivative of 5, which is 0. Derivative of 5x squared plus 10x minus 3. 10x plus 10. Because you take the 2 and you drop it in front to multiply. Go to the bottom, letter K. No. We gotta pause. We gotta, enjoy the moment. Think about doing this problem with the formal definition. F of x plus h minus f of x all over h is the limit as h goes 0. No. So Amber says that would not be fun. I'm giving you the option right now that if you would like to do this problem using the formal definition, you are more than welcome to. Go ahead and do it. You don't get anything, just the satisfaction of having fun. Well, again, tomorrow things are due. So Sam says he's money. Emily thinks she's got it. Wyatt thinks he's got it. I think Bo's off to a good start. Never mind. So I think we'll have some candy, but we'll see how the derivative comes out. But this problem right here, how long do you think? Just give me an estimation. If you were to use a formal definition, how long would it take you? You think an hour and a half? Till you cry. Okay. All right. An hour? Okay. Now, I need somebody to time us. Who's going to time us? Okay, Kimmel's going to time us. Kimmel, you tell us when to start, and we will take the derivative together. Kimball, tell us when to start. You guys tell me what's the derivative of 2x to the 7th? Then plus 3x squared. Done. Okay, so 22 seconds compared to an hour, or until you cry. All right. See how nice that is? It's so beautiful. Yes. We just, yes, very good. So if Taylor would like to, she could take a double derivative and just continue on going. We will talk about second, third, and fourth derivatives later on in this course. I don't really know if there's. I've never thought about that. If there's a formula for for a double derivative right off the bat. The only way I've ever done is just take the first and then the second. I, I don't know. That's a question. I think you need to take the first and the second. I don't know if there's any way around that. So yes. Oh, excellent. So, Ashwin, you ask a very good question. Okay. All right. So, if I am driving at a speed of 70 miles an hour down the road on the freeway for the course of 5 minutes, answer me this. What is my average speed over the course of that time? 70. What's my instantaneous velocity? 70. What is my acceleration? 0. So the second derivative is the rate of change of your velocity, otherwise known as your acceleration. So there is rhyme and reason behind all of these types of things. So if you are, at a stop sign and you're going from 0 to 60 in 5 seconds, you have, instantaneous velocity, but you also have acceleration in that situation. Or if you're slamming on your brakes. So that, and we'll get to all those situations. You'll begin to see them. So let's try problems that are more difficult, okay? Because those were easy. You have to make sure that you can write problems that are written as powers. So for example, this one falls apart. One of my favorite students of all time asked that I would do a review unit on exponents because they forgot the rules of exponents. I'm sorry, I will not do one for you. You should know how to do those. If you don't, please come and see me and I'll help you out. F prime of x is equal to, what? First of all, I'm going to rewrite f of x. I'm not going to do f prime yet. 8x to the fifth minus 3x to the third. And then how do I write that? 1 over x squared. Very good. Now it's in a power form that I can use according to my rule. I couldn't before. Minus x to the 1/2 power. So you have to be able to rewrite it in a form that you can then apply the rule. So f prime of x is equal to, what's the derivative of 8x to the fifth? 40x to the fourth minus an x squared minus 2x to the negative 3. A lot of people would put negative 1. Again, you're subtracting 1. So it goes from negative 2 to negative 3. Minus 1/2 x to the, what's 1/2 minus 1/2? Negative 1/2. You may not leave your answer with negative exponents. I'm sorry, 1/2 minus 1 is negative 1/2. So f prime of x is then equal to 40x to the fourth. That one's okay. Minus 9x squared. Now, does the 2 go on the top or the bottom? Which is it? What power is 2 being taken to? It's being taken to the first power. If it's being taken to the first power, does it belong on the top or bottom? The top. Only the x is being taken to the negative third. So therefore the x goes to the bottom. So minus 2 over x to the third. Does the 1 go on the top or bottom? Top. Does the 2 go on the top or bottom? Bottom. Because it's already in the denominator. It's a 1 over 2. And so the x to the negative 1/2 goes in the bottom, right, is the root of x. Some people say you cannot have a radical in the denominator. You can if it's a variable. If it's a number, you can't. If it's a variable, you can't. So this is the derivative, and we can leave it alone like that. You okay with that? As soon as you get frustrated that you don't like doing those problems, then just ask yourself, well, would I rather do it the old way? Okay? All right. Try a couple more, see if we can get done before lunch. First, I'm going to rewrite this. F of x is equal to negative 3 times x to what power? Thank you, Bo. Negative 5 over 3. So f prime of x will be, we'll take that negative 5 over 3 and multiply it in front. X to the, and subtract 1. Negative 8 thirds is what you get when you subtract 1 from negative 5 thirds. Oh, I never wrote the negative to begin with. I'm sorry. Thank you. So negative times a negative, a positive, and you see that the 3's will cancel. So what are you left with in the numerator? 5 over x to the 8 thirds. Now, this is where you got to be careful. This is acceptable. That is not acceptable because you can reduce the cubed root of x to the 8th. What perfect cube can you take out of x to the 8th? X to the 6th, which will reduce to x squared. So you would have to write it as 5 over x squared cubed roots of x squared. This is acceptable. This is acceptable. This is not. Because negative 5 thirds minus 3 thirds gives you negative 8 thirds. Because it was negative, I moved it to the denominator. All right, h, negative 2/5 times x to the 6/7. It's already in the appropriate form. F prime of x is equal to 6 over 7 times negative 2 over 5. X to the, subtract 1 from 6 over 7. What do you get? Negative 1/7. So I have 6 times negative 2 is negative 12. 7 over 5 is 35. And the x to negative 1/7, will that go in the numerator or the denominator? Denominator. X to the 1/7, or you could write 7th root. So you could write negative 12 over 35, 7th root of x, because you cannot take out the perfect 7th power. So again, now we got to write it as a power first. Okay. What makes I difficult? Yep. You must take care of that exponent first before you do anything else. You cannot, everything has to be written to a power as opposed to groups written to a power. It doesn't work to be able to take the derivative like that yet. We'll show you shortcuts later on to do that stuff. But let me just rewrite it. F of x, second hour didn't like this part, but f of x is equal to, I have a negative. What is 1/3 to the negative 2? 9. 1/3 to the negative 2 is the same thing as 3 over 1 squared, right? Which is 9. So that's the first step, to be able to write it in a manner in which you can take the derivative with the powers. So now f prime of x is equal to negative 9 times negative 2. 18 x to the negative 3rd. Does the 18 go in the top or bottom? Top. How about the x to the negative 3rd? X to the 3rd in the denominator. That's your derivative. And we have one left. And then you guys can head off to lunch. By the way, I don't see people running out of class right now, getting to lunch early. I look like a what? I look like a plum. Would you like me to tell you what you look like? Okay, all right. All right. Yeah. That started with a different. There was a student who used to call me pumpkin. Yeah, well, she felt weird when she said. I said, "Isn't that a term of endearment? You know, calls me pumpkin. Hey, pumpkin." You know, so then she started blushing. So, all right, here we go. Let's try to break this up a little bit. Look at this. What's the derivative of the square root of 3? 0, because the square root of 3 is simply a constant. However, some people write this as 3 to the 1/2, then they'll drop the 1/2 in front times 3, or the negative 1. It doesn't work like that. It's a constant. You take the derivative, you get 0. So we don't have to worry about that. But I do need to worry about the square root of 5x. Square root of 5x can be rewritten as square root of 5 times square root of x, or square root of 5 times x to the 1/2. So that's what I'm going to use in this scenario. So I'm going to rewrite f of x as square root of 5 times x to the 1/2 minus the root of 3, which will not matter at all, plus x to the 1/2. Anytime I have a variable, I write the power in rational form. I would like to do that when I actually write derivative, because I've just rewritten the function. Because this is the function, is it not? The same thing as what I have there. Now when I take the derivative, I'll go ahead and get rid of it. So, yep, we'll finish it off when we get back. All right, I hope you had a good lunch. Let's finish this problem off. No, I do not have lotion. I don't care. All right. Does everybody see how I came up with f of x? Okay, once you've got f of x, then apply the rule for f prime of x. So we drop the exponent in front. So we have 1/2 times the root of 5 times x to the what power? Negative 1/2. What's the derivative of root of 3? 0. Plus 1/2 times x to the negative 1/2. So f prime of x is equal to, where does the 2 go? Where does the square root of 5 go? So square root of 5 over 2 x to the 1/2, or root of x, plus 1 goes on top, 2 goes on bottom, root of x goes on bottom. Are those common denominators? They are, so let's just combine them together. Root of 5 plus 1 over 2 roots of x. Do you remember when you found derivatives of, say, square root of 2 plus x, and you would get 1 over 2 roots of 2 plus x? Do you remember when we were multiplying by the conjugate, how the square root always ended up in the denominator? That's why, because when you subtract 1, it becomes negative 1/2. So you're seeing that now, okay? So you can anticipate what's going to happen. So that's it. YouTube Nation, I got a worksheet for these guys.